Hello everyone. Here, in continuation of properties of soil, we'll be discussing in this session about in situ density by core cutter method. There are other methods, but we'll be studying in this session core cutter method. The reference is IS 2720, part 29, 1975. Okay, in situ density or field density. First of all, what is meant by density? Density is a ratio of mass to volume, or it can also be told as mass per unit volume, because when you divide it will be per meter cube, right? Mass is measured in kg, so density is measured in kg per meter cube. It is mass divided by volume. This particular relation we use while finding out mass also. Mass of given volume of a material, if you want, will multiply volume and density to get the mass. So one should be knowing about density is equal to mass divided by volume. Okay, now what is meant by field density or in situ density of soil? Now field density or in situ density is the density of the soil as existing in the field in its natural state. So here there is a natural state soil, right? Now if I want, this is section of soil, if I want the density of the soil, now for example I'll take a cylinder out of it, right? How do you take out this cylinder? So that I can measure this diameter, this height, and then take the mass. So by knowing the diameter and then height, I can calculate the volume. Mass can be found by the balance. So mass by volume will be, but how do you exactly take out a cylinder out of natural soil deposit? It is difficult, it is not that easy. But suppose if you are given a piece of a wood or something like that, you know how to find out the volume and you can find out the mass also. It is easier, but soil, if you excavate, what happens is it loses its shape. You will not be able to know what is the volume, though you can calculate or find the mass. What exactly the volume, that is difficult to know, right? So we'll see how it can be found in further slides. Now what is the use of, or what is the purpose of knowing the field density? Field density is used in many things, right? Immediate use that you will be finding is in calculating White's ratio, porosity, degree of saturation. All these terms we have already defined, but how do you find this? These things are found indirectly by knowing the density. That's an important application of field density, right? And also you will be knowing that relative density of cohesion-less soils is found by knowing the density. And then other applications are there: stress in soil due to its overburden, bearing capacity of the soil foundation system, settlement of the footing, earth pressure behind the retaining walls, stability of slopes. There are many things in which we need to know field density or density of the soil as existing in the field. Okay, this is you should know the mass of the soil excavated and then volume. It is difficult to know as it is, so there should be some good means through which we can know this. We'll see here. So equipments required for finding out field density by core cutter method would be cylindrical core with steel dolly. So here there is a photograph which shows a cylindrical core. The core is nothing but a piece of a pipe cut nicely with a beveled edge here, so that it can easily penetrate into soil. and there is a steel dolly. Dolly is nothing but a ring which will be placed on top of it, right, so that this core will not be damaged or it will not be losing its shape. To take care of that top edge while it is being penetrated into the ground, you have to put a dolly on top of it. Okay, then next is a steel hammer, not hammer, steel rammer of mass 9 kgs. This rammer that you see is 9 kg. Overall length is 900 mm. That is the length of this is around almost a meter length. Okay, so these are the things that we have already here: core cutter, steel dolly, and then a rammer. Then you need a balance, maybe a digital balance, or a digital balance would be accurate because we need an accuracy of 1 gram, so we'll be using balance. And then additional things that you should have is palette knife, spatula we call it as, straight edge, steel rule, trowel, pickaxe, etc. we need. Now we'll see further how it will be done. Procedure. So here we have a core, schematic diagram I have drawn. This is a core. Measure the internal height and internal diameter of the core cutter to the nearest of 0.5 mm accuracy. Calculate the internal volume of the core cutter VC in centimeter cube. So you have to measure H of inside, D of inside, and then calculate VC equal to pi D squared by H. This should have been square. Actually it is not that way, so this is not the way. Pi D to H, now pi D squared H. We know that pi D squared by 4 is nothing but this area, circular area, multiplied by H gives you the volume. So volume of core, volume of inside of the core is pi D squared H by 4. That is what you have to find. And if you have measured these things in centimeter, you will be getting so many centimeter cube as the, or cc as the units of measurement. Next is determine the mass of the clean cutter accurate to 1 gram. Means you have to take this particular core, put it on the balance and find out the mass of this. We call that as M1. So mass of the empty core cutter is equal to M1 grams. In grams we'll be measuring. Now select an area. You can just see here there is a ground that has come, and then we'll place this, clean the ground of any loose pebbles or material, and then place this. So select the area in the field where the density is required to be found, clean and level the ground where the density is to be determined. Now place the core and put the dolly on top of it. So you put the dolly now over the top of the core cutter. Dolly is put over the top of the core cutter, and press or ram the core cutter into the soil using the rammer. Now stop ramming when about 15 mm of the dolly is still above the soil. Means when you go on ramming it, this gets inserted into the ground. So the soil level should not come under or up to the level of the dolly. It has to be inside. How much inside? Approximately around 15 mm, right? 15 mm, 1.5 centimeter, roughly around 1 to 2 centimeter range you should leave, right? Till that you have to ram it. So you put ram so that this core along with the dolly gets penetrated inside, and then you have a clearance of 1.5 centimeter. Now what you have to do is you have to excavate this soil, right? You have to excavate all this soil by some means, so that you will be able to hold this particular amount of soil, right? So take out this particular mass of soil and then clean the outer surface, and then go to the lab, level off the soil, level of the soil from the top after removing the dolly. That's what is written here. Remove the soil surrounding the core cutter by digging using spade up to the bottom level of the core cutter. Lift up the core cutter and remove the dolly, and trim both the sides of cutter with a knife and straight edge. Clean outside surface of the cutter and determine the mass of the cutter with the soil, and that is M2. So you have mass of the core, not empty core, mass of the core plus soil from the field is equal to M2 grams, right? And then if you take the difference M2 minus M1, we get only the mass of the soil. So mass of the soil inside the core will be M3, which will be equal to M2 minus M1, so many grams. Now you know the mass of the soil inside that core. We know the volume of the core also, assuming that we have not disturbed the soil. Now if you take the ratio, field density or field bulk density is equal to, represented by the letter rho, will be mass M3 divided by the Vc, so many grams per cc. That is what the density or field density of the soil will be. Okay, thank you. Stop here.